Yes, dear students, welcome to very important video, which creates lot of trouble for competitive exam also. The heading here is radiation pressure. Radiation pressure. क्या वैसे radiation pressure. People generally don't understand what is the meaning of radiation pressure, the force upon area. To do electromagnetic wave apply force on a body on which they are falling. Yes. Do they carry energy? Yes. We know electromagnetic wave, EM waves, consist of oscillating electric field and magnetic field. Due to these two fields, there is an average energy density that U bar is equal to half epsilon 0 E0 square equal to B0 square upon 2 mu 0. Then it is theoretically we have obtained, but practically how to realize that this energy is there. I gave you example of our antenna of TV, radio. So the same way, if we consider a metallic plate which intercepts the EM waves, metal plates has free electrons which are set into oscillation, and every oscillating particle has momentum energy. So momentum and energy is imparted by EM waves in free electrons. Due to that, you get the signal from TV antenna. Moreover, other example we don't get satisfied. When we sit in the sun, secondly, when we sit in the sun, light, our body gets warm. So from where we have got heat energy from EM wave, and this is due to heat energy given to our body by the EM waves falling on our body. I am telling in very simple language. जब हम धूप में बैठते हैं तो हमारी बॉडी गर्म क्यों होती है? बिकॉज वी आर गेटिंग हीट फ्रॉम सन. सूरज की धूप में बैठते हैं, हिंदी में कह लीजिए, तो हमारी बॉडी वार्म होती है. क्यों? फिर क्वेश्चन था बॉडी वार्म भी क्यों होती है, ये भी पूछ सकते हैं आप. आवर बॉडी हैज ब्लड रनिंग इन आवर arteries and veins which have ions. Blood is in the form of ions there. Those ions get impulse from electric field. The amplitude of vibration increases and they collide with each other and with the skin. And temperature get, when two bodies collide, heat produced. So this way we can prove that electromagnetic radiation carry heat energy. Now, the heading was radiation pressure. It can be proved. It can be proved, not here, that if capital U be the energy absorbed by a surface in time t, then momentum P imparted, जब डेल्टा P करेगा, momentum imparted to the surface is given by delta P equal to U upon C. What is U? C, where C is the speed of waves, यानी कि स्पीड ऑफ इक्वल टू स्पीड ऑफ लाइट. U is the energy falling per unit and in time t on the surface. Now pressure changing momentum per unit time is called force. Changing momentum per unit time is called force, and force divided by area is equal to pressure by delta P upon delta T is equal to force, and F upon area is equal to pressure P. And this pressure imparted to the body is called radiation pressure. When I became teacher, I learned these things from books, but was actually in difficulties how it is happening. Now, I will explain you, I will derive formula in terms of intensity. If capital I be the intensity of radiation, that is EM waves, falling on area A, then energy received by surface in time t, या डेल्टा टी करिए आप, क्या होगी भाई वो? I write that delta U is equal to I into area into delta T. Intensity is the amount of energy falling per unit area per unit time. Sorry, actually there was little tilted. Here if I be the intensity of radiation, that is EM wave falling on area A. So what is intensity? Intensity I told you, energy upon area into time. So energy falling delta U, this, and hence the change in momentum of the body on which waves are incident, delta P equal to by delta U upon C यानी कि IA into delta T upon C. It should be very clear. Please listen it carefully. This has not been derived in any book. For sake of simplicity and for understanding what is happening around us, I want to take you beyond that blind faith के होता होगा, चलो मान लेते हैं, नहीं. Delta P upon delta T, but F is equal to delta P upon delta T. So here this F is equal to IA upon C. This is another a good question. Force applied. But why don't we feel force? Actually, I will tell you one example. This force applied is very small. Our body has large mass, so we don't feel. Like if photons are falling on this earth surface or our body from the bulb, I am not feeling any force, but it is this. If I the intensity, A is the area of my body, C is the speed of light very large, this force becomes very small. And pressure is equal to force upon area. Pressure is equal to force upon area. So pressure P equal to, or P equal to divided by I upon C. So this is the pressure exerted by a body due to radiation of intensity I and C is the speed of light. And this pressure is called radiation pressure. So I was telling that I learned many questions. So you have learned comet. Have you heard about comet? Sorry. कमेंट भाई यार बोर्ड खराब हो गया. Comet are the heavenly bodies which move around the sun in highly elliptical orbit. हिंदी में इसको कहते हैं पुच्छल तारा. तो वह वो पूंछ क्यों बनती है? उसका रीजन है रेडिएशन प्रेशर ड्यू टू सन. When it come close to sun here, due to large radiation shed by it come very close to sun. तो a tail is formed away from the planet. ऐसा टेल बनती है. तो इट इज ड्यू टू रेडिएशन प्रेशर. I have read many books but no such derivation. There is one example in our book. NCERT book is there. And there are two questions based on this fact. Please listen this carefully. And no teacher bother to solve these questions. Here is example 8.4. Example 8.4. Example 8.4 of NCERT on page 279. 279, yes. What is saying? Light with an energy flux of 18 watt per light of an energy flux. देखो कैसे नाम देते हैं, एनर्जी फ्लक्स of 18 watt per centimeter square. If we don't explain what is the flux, actually amount of energy falling per area per intensity है. Intensity of light falling is 18 watt per centimeter square. Fall on a reflecting surface. Sorry, एक मिनट भाई. अभी हमने किया ये U upon C. तो एक body light get absorbed totally तो this. If get reflected back, तो वो twice हो जाएगा. खैर ये क्या कह रहा है? Light with an energy flux of 18 watt per cent falls on a non-reflecting surface at normal incidence. If surface has area 20 centimeter square, area 20 centimeter square. Find average force exerted on surface. Average force on surface during 30 minutes. Time is area 30 minutes. तो ऐसा पूछा फोर्स. तो इंटेंसिटी जो है ये कितना है? दिस इज एनर्जी फ्लक्स विद इंटेंसिटी 18 वाट पर सेंटीमीटर स्क्वायर. it is 18 to the power minus plus 4 watt per meter square by centimeter square converted to meter square. And watt means itne joule per second. If I equal to 18 into 10 to the power 4 watt per meter square, it means energy falling on 1 meter square area in 1 second is this. So total energy falling क्या होगी भाई? इंटेंस इंटू एरिया 18 इंटू 10 to the power 4 और एरिया था वो 20 सेंटीमीटर स्क्वायर. 20 इंटू 10 to the power minus 4 मीटर स्क्वायर हो जाएगा. इन 1 मिनट टाइम है 30 मिनट. 30 into 60. If you want to calculate this much is the energy, then momentum delta U. Delta U is equal to delta P. Change momentum. Sorry, मैं आता हूँ. Delta P is equal to P momentum है, not pressure. This upon C. 18 into 20 into 30 into 60 upon ये कैंसिल होगा C 3 into 10 power 8. But he is asking force F equal to delta P upon delta T. 30 मिनट ये दे रखा है. तो लेट बी राइट एट डेल्टा टी. तो बाद में देखेंगे. तो डेल्टा पी अपॉन डेल्टा टी इट इज 18 into 20 upon 3 into 10 to power 8. कितना हो गया? 360 120 10 to power minus 8 न्यूटन और 1.20 10 to power minus 6 Newton. It is this force applied due to radiation. So please try to understand this topic here. Actually, I have seen question comes on this topic in competitive exam. Board people have not dared to ask this question because, but later or sooner some question may be there. If you want to find pressure, radiation pressure, this वो 20 मीटर स्क्वायर सेंटीमीटर स्क्वायर एरिया है, उस पर ये फोर्स लगा. दिस फोर्स डिवाइड बाय प्रेशर, वो एरिया विल गिव यू प्रेशर. तो कितना है फोर्स? हाउ मच इज दिस फोर्स? तो प्रेशर एक्सर्टेड, प्रेशर रेडिएशन प्रेशर ऑफ दिस रेडिएशन 1.20 10 to power minus 6 upon 20 centimeter square 10 to power minus 4 meter square. So it will be how much? Uh, 120 upon 2 10 to power minus 3 बच गई. तो 10 to power minus 3 बचा. भाई ये 3 होगी माइनस की और ऊपर जाके प्लस की. यस. तो इट इज 60 into 10 to power minus 3 और 6 into 10 to power minus 2. गलत हो गया, कुछ हमसे गलत हो गया बच्चों. इतना करने के बाद भी गलत होता है. हाँ, प्रेशर गलत हो गया भाई. 20 सेंटीमीटर स्क्वायर था ना और 1.20. ओह, आई लेफ्ट दिस 1.20. भाई तो इट विल बी हाउ मच? 1 मिनट. 1.20 into 10 to power minus 3 upon 2. Yes, son. 20.6 और यानी कि 6 into 10 to power minus 4 Newton per meter square. So you can calculate radiation pressure this way. It has become longer. Now I will be telling one more question here to find the magnetic field of radiation.